Hello students, a very warm welcome to JEE English Unacademy, the India's leading and largest JEE test preparation platform. And guys, today we are going to explore the DPPs on capacitor, and today we are going to mostly take up problems on like the JEE advanced model problems, and mostly like also the JEE advanced PYQs on capacitors. It's going to be very interesting, but at the same moment, make sure you are working along with me, and you should not ever get discouraged by if you're not getting answers or something. It's absolutely fine. This session is meant so that you can understand the concepts. Don't worry about it. It's a very easy chapter, guys, and I'll make sure there are very easy techniques to solve problems. We'll discuss that as well. And make sure that you are also sharing this video, because like JEE English is the nation's first channel where you get all your content for your JEE preparation from basics until advanced, exclusively and completely in English for free of cost. So make sure you share this video and you click on that little subscribe button and bell notification. And students who know me well and good, if not, I'm Muralidharan GopalKrishnan. I completed my MS in Electrical Engineering from University of Colorado Boulder, one of the top ranking American university in electrical engineering, and also an IITian who graduated from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. And guys, I have filed even patent applications on electrical engineering, so don't worry about this chapter. It's going to be super easy. All you need to do is stay focused and make sure you share this video and ask your friends to come on board. It's going to be super easy, guys. And that being said, check out our Telegram channel, and you need to first of all download Telegram app from your Google App Store and Play Store, and then what you need to do is click on to this link which is available in the description box below. Make sure you're clicking onto this link so that you can get all the timely updates. And not only that, guys, you can also just type in JEE English, so you can get all the updates on our special classes, on anything like special Sundays, special Fridays, and special Saturdays, or any regular sessions, and what is that like what is happening in our on our JEE English channel. Not only that, we share DPPs and problem sets on this Telegram channel. So make sure you get onto this channel to get timely updates on what is happening on JEE English channel. And that being said, students, we have conducted a one-shot class on electrical instrumentation on Unacademy Learning app. Do check it out. It's a very important chapter for your JEE Advanced preparation and JEE Mains preparation. It's quite easy. As you know, in current electricity, most of the chapters are independent of each other. So make sure you're attending this class and cover all the different concepts that have been discussed. I've made sure that all the concepts have been covered in this class. So go and visit it. It was conducted on 1st of September. It's a free of cost special class, guy. It does not take anything. So go and attend it, students. It's not going to take any time, but it is also worth your time. So make sure even before your JEE Advanced, you're covering this class. And that being said, this Sunday for your JEE Mains and JEE Advanced preparation, we are going to discuss projectile motion in one shot, and we'll take up many problems around projectile motion, and that too around your JEE Advanced topic. So make sure you're attending this awesome 2D motion class, and it's at 11 a.m. on Sunday. Make sure you're attending it, students. It's going to be awesome. It's easy chapter. We have already conducted some classes on JEE English, but we are going to discuss many more model problems. Make sure you're attending it. It's very important for your JEE Advanced preparation. And students, do check it out. Do check out even the previous classes conducted on Unacademy Learning app, and make sure you're understanding everything. And if not, you can comment, or you can come to the live classes and ask us any doubts that you have. And students, that being said, to attend these free of cost special classes happening on Unacademy Learning app, all you need to do is download the Unacademy Learning app, of course, and you need to type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy Learning app, and you will click on that, and you will click on the install button, and this will give you all the timely live updates, and also in advance updates on what is happening on Unacademy Learning app. So make sure you are downloading this Unacademy Learning app, so that even if you're a plus student, it will help you a lot, students. And that being said, students, if you're preparing for IIT JEE and if you're looking for an awesome platform for your JEE preparation with the top-notch educators across the nation, we have one for you. And guys, it comes with all the things that is necessary for your JEE preparation, be it live test series, be it live quizzes, be it you want some personalized insights on your JEE preparation. You can avail everything, and all you need to do is you need to of course purchase a subscription, but it's a very economical subscription, students. And not only that, on this platform you get access to like the state of the art education tech, where you get to do things in real time as if you're in your exam. So make sure you're on this platform if you're preparing for JEE, so that you can take up all the time tests. Of course, Unacademy delivers a lot of free of cost lectures, but this is an awesome platform for your JEE preparation. When it comes to your JEE preparation, you need something that can keep track of your progress in terms of tests, because it's of course a competitive test, and you need the best educators, you need the best platform, and we have that for you. And all you need to do is click on that extension bar and click on that this plus icon, and then choose IIT JEE as your goal. And be sure to choose IIT JEE as your goal. As you know, it's very easy. And let me tell you something, guys. All you need is proper preparation, and it is possible. And be focused on your target, and be it on your JEE English channel or your Unacademy subscription, and you need to be super focused on your target. And post this, all you need to do is you need to get the subscription. And guys, if you already have subscription, do keep attending those test series, keep attending all the structured program. It comes with awesome structured program. You have weekly classes, and not only that, you get to attend quizzes every week on the topic that has been completed, and also a test series is conducted. And that being said, students, the subscription is economical. It's only going to cost you 2,100 per month after applying Murli live coupon. So all you need to do is you need to get subscription, and then you will choose the program accordingly. But anyway, if you are in 11th class, 9th class or 10th class, make sure you are going for a 24-month subscription, because that is going to save you a lot of bucks. Not only that, guys, it's an awesome platform for your JEE preparation, and you need 24 months anyway for your JEE preparation. It's a 2-year-long journey, there is no doubt in it, especially if you're in 11th class or 9th class or 10th class, or if you decided to give 2 years to your JEE preparation. Stay focused on your target, and we have the best educators across the nation on this platform. And students, not only that, we have Mr. DC Pandey sir on this platform, who is a very renowned author in physics. So you don't have to have any second thoughts. And if you're in long term or dropout, you can go for a 12-month subscription, and that's going to cost you 34,000 near about 34,500 650, and that to inclusive of all the taxes. That is only less than 2,900 per month. And guys, 24-month subscription is of course economical. It's going to be only 2,100 per month. That's quite economical for the kind of value that you will get, the kind of education that you will get from our best educators across the nation. And that being said, students, don't focus on your obstacles, but be focused on your target. Have your dream set, and make sure you are focused on your dreams and your target, and you need to work hard to achieve those goals. We are giving you the best content. If you're on subscription platform, you're getting everything that you need for your JEE preparation. And if you're attending lectures regularly on JEE English, you get all the lectures for free of cost. So do share this channel. But also like this video. But you should be dreaming about getting into those awesome IITs and NITs, guys. That's where your target should be. That's where you should be focused on. You should ignore rest of the stuffs, and you should be attending quality lectures. We are of course giving you all the quality lectures on JEE English. You can check out any lecture on capacitor, and let me know if we haven't covered any concept on this channel on any of the topics that we have conducted. I'll make sure I'll cover that as well. So check it out. Check out all the previous lectures on JEE English, and also check out all the lectures on your Unacademy learning app. And make sure you're focused on your targets, and you keep dreaming about getting into those awesome IITs, guys, and NITs, where you get access to the best infrastructure, best research facilities, and best playgrounds. Of course, you get access to awesome sports facilities. Don't get discouraged anytime during your any of these sessions, or any of your exams. Those are meant to be like that, students. No one is succeeding in the first attempt. No one is cracking right away JEE Advanced problem. It takes some time. So don't worry, today we are going to discuss some awesome JEE Advanced and some JEE Mains problem as well. But you'll see how easy are those problems, and then you will understand it's a very easy journey. So let's get into the challenge problem number 1. So it says that there are two capacitors, C1 and C2, that are charged to 120 volts and 200 volts respectively, and it is found that respectively means generally it is saying that C1 is charged to, if you have ever come across this term and if you have any query, so this was like a confusing term for me earlier, so that's why I'm explaining you. So respectively means C1 corresponds to 120 volts and C2 corresponds to 200 volts. Given anything, mass M1 and M2 respectively, that means M1 corresponds to some 1 kg and M2 corresponds to some 2 kg. Okay, and it is found that by connecting them together, the potential on each plate on one can be made by connecting them to each other. Can the what is going to be the potential can be made 0. So this is a previous year JEE Mains problem. So they are saying, so what do you think? How would you connect the capacitors such that the potential can be 0? Think about it. Take your time, and given to you many options, and let me tell you something about it. Okay, before we get into this problem, generally there is a thumb of rule in these kind of problems. So if you notice, so they have given you many confusing options. Of course, there will be like distracting options. That's the goal. See, like if you see, this is 1, this 3 are like distracting options. Probably your answer is around this. Okay, this is a technique, not necessarily your answer can be also D. We need to analyze that. You need to work it out. So what does it mean when you are going to connect two capacitor plates together? You are going to get 0 potential on each plate. Then what is happening actually? Think about it. Think about what should be the polarity such that you're going to get 0 potential about it. How would you connect it, and what should be it? So let's get into it. So let's say you have 2 plates, and this is 1 plate, and this is charged, this is C1, and this is charged to 120 volts. And let's say you have C2. Okay, and this C2 is charged to 200 volts. So what is the problem stating? If I am going to connect both of these plates, the potential would become 0. When is that possible? When is that possible? Any guesses, guys? Think about it. Let me tell you something. If I add plus Q over here, and let's say it's plus Q and this is plus Q dash. Okay, some charge before connecting it. Let's assume we haven't connected these capacitor plates. Then is it possible to get 0 potential? No, of course no. So then when it is possible, this cannot be plus Q dash. Okay, all with sign convention, this has to be minus Q dash. So they have to be connected in opposite ways. There was also a JEE Advanced problem on a very similar concept. Okay, so generally students think, okay, this has been connected, we need to. So what would you do when 2 plates are connected? You will be equating the potential. You know that. If I'm going to connect these 2 plates, you're going to basically equate the potential. Right? You're going to equate the potential. And how do you equate the potential in this case? So one of the ways to think about it is, this potential should be equal, and you can apply, Kirchhoff law to understand this point. And let's do a thing. I'm just going to, erase this 200 volts and 120 volts and write it above, so that we have the best clarity. So let's say this is 120 volts. Okay. So when is this possible? So when you have to connect them in the opposite polarity, right? And this is an isolated capacitors, so there is no battery in between them, there is no ground, etc. They are just connected, and the potential on each plate is becoming zero. Right? That is what is told to you. Then what is happening? Probably these charges are flowing and making sure that the capacitance becomes the voltage becomes zero. Right? Let's get started on this problem then. So you are going to do a couple of things. One is you have to make sure both these plates are at same potential, and that is given to you. They are going to be at zero potential. Okay, so there is no use thinking about this potential thing. And the other one is probably the capacitance C1 and C2 are holding the same amount of charges. Let's verify that and let's come to the conclusion. Okay, so one equation, the standard equation whenever you are going to connect two plates is you're going to write down, first of all you're going to assume initially they were at different potentials. Here it is already given to you. Even if they haven't given you potentials, they have given you charges, you're going to do that. Okay, so they have given to you, so that's not something that you have to worry about. And they have told you that this potential on the plates has become zero. It's going to be charges will be conserved, so there is going to be new charges. The earlier charges is nothing but Q is equal to CV. Okay, and one more interesting thing told to you is this charges is if you add up these charges, they are going to be zero. Okay, so that is saying that but in opposite polarity, isn't it? Hi Shubhashri, hi Shubhashri, Priyadarshini, hi, how are you? So get started on this problem. It's a very easy problem. So couple of things you have to remember: the potential should be equated, and the other thing is you should be equating the charges. Okay, net charges should be equal. Okay, net charges should be equal. And they are connected in opposite polarity. What is charge on Q1? Let's call this Q1 and Q2 so that we have a better understanding of things. So I'm going to call this as Q1 and this as Q2, right? So that means 120 C1 opposite polarity minus 200 C2 is equal to 0. Right? So that means just a moment. That means how much is this? This is going to yield you some equation that you have to verify. And the other thing you can do is you can go by the traditional potential method as well. You'll cancel it out and you'll find out some relationship between. This is because it's an opposite polarity, right? Minus, else you would not do minus, right? Okay. When will the potential be zero? Q is equal to CV. Capacitance is zero. Only when the new Q is becoming zero, that's when the potential is going to be zero. Right? So that's what you have to do. It's a very simple problem. This is going to be, I guess this will go by 4. This will go by 4. So this is going to be 3C1 is equal to 5C2. That is when it is possible. Right? So let's check out the option. So they have given you two options which are confusing. Of course, this is not correct. This statement itself is false, and this is given to distract you, and this is also not correct. Okay, so you know the right option now. So let's move on to the next question. It's an easy one, and the next one is also going to be super easy. So an air-filled parallel plate capacitor has a capacitance of 2 picofarad. The separation between them is doubled and the interspace is filled with wax, and if the capacitance is increased, so two things have been told to you. One is the separation between the plates is doubled, and the other one is the interspace is filled with wax. If the separation is doubling, what is happening to the capacitance? It is going to become half. Okay, and you're filling it with wax such that it has become 6 picofarads. Okay, you can directly say the answer is 6, but let's understand this. Okay, so your C1 was 2 picofarads, and what did you do? You took the distance and you doubled it. d dash is equal to 2d. That means now c dash is going to be c1 by 2. 1 picofarad is what it should have been. But your wax has some dielectric constant that is making sure your K wax into C dash is equal to 6 picofarads. How much is that giving you? C dash is 1 picofarad and K wax is how much? 1 picofarad. Make sure you are equating the units, and in problems like this all it is about units. So K wax should be how much? It should be 6. But you could have right away answered it without any hassle. So let's move on to the next problem. Then I guess this was an easy problem, so the answer should be 6. We just discussed it. So yes, whenever you see these kind of problems, what would you do? You would label the plates. We discussed even a bit more advanced problem during our regular sessions. All you need to remember is you need to keep on. Yes, Ashish, we'll cover the complete syllabus. In fact, Ashish, the thing is we have completed the entire syllabus on current and electricity and capacitors. We are right now on DPP session. That means we have covered capacitors. Okay, A to Z of capacitors and A to Z of current and electricity. We also often keep on conducting the this topics on Unacademy Learning Web with different model problems. Be sure to check out both. But we have covered pretty much everything. So make sure Ashish, you're attending it. Your syllabus will be complete. Don't worry about anything. Okay. And what are they asking you? Between X and Y, what is the equivalent capacitance? What would you do in these kind of problems? In these kind of problems, there is simple things. There is also simple thumb of rule. Okay, whenever it comes to any problems related to current, electricity, or capacitors, anything to deal with electronic engineering, there is a standard thumb of rule. All you need to do is label the plates, and then you'll see the problem becomes super easy. Any guesses, students, before we get started? What should be the capacitance of this arrangement between X and Y? Anyone? Good evening, Shurya. Good evening, Shubham. Hi, Shubham. Hi, Shurya. Shaurya. Hi, Shaurya. And hi, Shubham. Any guesses, students? How do you do this? And how do you do this is what I told you right now. How do you work around this problem? What is going to be the answer? Okay, I'll get started on this. Until now, you can think about it. Let me tell you, generally in these kind of problems, if you see multiple plates and only there are two equipotential plates and two terminals, there might be a Wheatstone bridge. I don't know yet. Okay, I don't know yet. So let's say this is 1. You will label this as 1. This also 1 then. And what about this? This plate is going to be 2. Okay. This is going to be 2. Separate plates, right? Whenever you see a problem like this, just label the plates and try to arrange the terminals such that the capacitor plates match. That is all you have to do, guys. That is all you have to do. Okay. So this is X. For X and Y, I'm just choosing the same color because you know what it is like. They are like terminal plates. So let's first of all, we need to find out between X and Y. I'm first of all going to draw X, and there you go. And you will have X, and between that X, this X is going to have 2 plates. Between them, one is going to be 1 and the other one is going to be 2. Okay, and let's get started with this. And this, if I'm going to say, so let's do a thing. Let's for better understanding, we'll just draw it upside down, and then later on you can convert the circuit. So let's do a thing. We'll just get started with 1. We'll go in the order because if the plates were very complicated, right, then it would maybe create a problem depending upon the type of problem. So let's start with 1. It's going to be 1. And what about the next plate? The next plate is going to be X. Okay. Now match this X, pull this X, and put this X over here, and then use the 2. And do remember, students, in this case it was given to you the capacitance, these plates have equal distances. If not, you would have to accordingly work on the problem. This is D, this is also D, this is also D. All these things, all these distances between the consecutive plates are D. If not, you would have to change your way how you do it. Okay, so that means that this X and X. Okay, I think this D is distracting, but anyway, let's keep it for now. And now what about this? This is, again you have between two, I don't know, Amber, I can't comment on that. You can attend classes on Unacademy. That's your decision, right? And how about this? And there is 2 and 1 right now. So you need to understand that 2 and 1 are also connected somehow. And how? I'm just going to say this: the terminals should match. If not, there is not 2, there is not 1. This 1, and that's going to be it's equal plate, equal distant capacitor. This is going to be 2. Right? There is your X. Your X is over here. You're going to assess between X. This is your X. I could have drawn it that way, but I hope this gives you better clarity. I've taken 1. That is what I did over here. Then we went to X. Yes, one capacitance exists. Then there is again plate X with a capacitor. With another plate 2. Again there is 1 and 2. If you notice it over here, there is 1 and 2, isn't it? So there would be another capacitor. Then 1 and Y would also form a capacitor. Quite an easy problem, huh? Until now, I haven't observed a very similar problem in JEE Mains or JEE Advanced. I've only observed in terms of spheres, but that means there is a high probability you might get a similar problem like this in the coming up years. All are C. Can you observe something? I told you, generally in problem like this, I hope it's sort of good evening, Tej. Good evening, Tej. Hi, how are you? Long time. And this is going to be Y. That means what is happening over here? This is on a Wheatstone bridge, isn't it? Aren't we? Isn't this point at equal potential? That is only when the distances between the consecutive plates are equal. Do remember that. So Shubham, what about this channel? This channel, as well as any other Unacademy channel, we deliver quality content for your JEE preparation from basics until advanced. One of the things we are doing unique over here is we are delivering all your syllabus until you're advanced. We are trying to cover maximum model problems, and we are delivering content exclusively in English. So that many times you tend to stumble upon the problems where you get it in English. So that is one of the reasons. The other thing is that it should not be a language should not be a barrier for your learning. So that is also one of the things we are focused on. So that way you get a lot of things on this channel as well. So there is C. How is it arranged? So I'm going to call this 1. This as this 1. This is 2 and this is 2. Probably this 1 and 2 are in Wheatstone bridge. Generally in problems like this, generally it is in Wheatstone bridge, but you have to always draw the circuit diagram to ensure things. Right? Then X, this also X. So that is the specialty of this channel, guys. Okay, and we have IITMs on this channel, just like any Unacademy's channel. That is also one of the things. And not only that, we are taking you until the advanced level. There are many advantages. So C and C, it's going to be basically C, right? Wherever you see a configuration like this, be it in resistors or capacitors, you can directly state that the equivalent capacitance is nothing but C. So it's C by 2 and C by 2. And then C by 2 in parallel is going to be C. That's it. So what is the value of C? Epsilon naught A by T. That's it. Quite simple, pretty straightforward. Yes, Shlok. I mean, of course, you have to go through JEE main syllabus for doing your JEE advanced. We cover at both levels because it's a two-step thing. It's not a one-step thing anymore. So earlier during our times it was like one-step thing. Now it is like a two-step thing. So we cover both JEE mains, JEE advanced, and also give you with all the basics. So for an example, in capacitor, pretty much we have covered so many concepts. How do you derive capacitance even if you don't know anything about electrostatics? So in my lectures, I made sure, So think about the capacitor lectures and the current and electricity lectures that I've covered is I've made sure each lecture, has some prerequisite information that you need for solving or understanding the concept. And not only that, from starting from everything like charge distribution, how do you derive that Gaussian surface, what are the electrostatic forces between plates, electrostatic pressure, and how do you solve for different capacitor problems, charging and discharging of capacitors. You covered so many things, and even in combination there are different kind of combinations. In the next upcoming session we'll take up on cubic arrangement of capacitors. We did it for resistors as well in the current and electricity lecture. So these kind of things are covered generally on this channel. Okay, and I come every day at 7:30, students, so stay updated on the lectures being completed and be on time, guys. I mean, like be on time to lectures as well. I mean, at least as far as covering the lecture, I mean, you need to be updated with the syllabus. I mean, you need to be on step with us in the syllabus, so that you don't lag anything, you don't have any backlogs. Even if you're on Unacademy subscription platform, don't ignore tests, students. Okay, so let's get into the next problem, and this is an easy one, guys. Let me tell you, this is a simple one. Would there be any capacitance between these plates? Would there be any energy stored between these plates? If these two plates are connected, what do you think is going to happen? And is this capacitors in parallel or series? SHM, backlog of SHM, will take up SHM, simple harmonic motion. Yes, we'll do that. The backlog, you have to watch videos, guys. You have to watch videos, make sure you're attending test on time, and that is how you will cover the backlog. Backlog, you have to give the time. If you're way too behind, then take up rest of the topics that has heavier weightage. Okay, let's say you have missed capacitor lectures, you have missed some specific part of capacitor. Okay, if you're attending combination of capacitors, make sure if you attended one and if you attended three, make sure you're also attending the second one, because some other kind of different concept is being discussed there, and that is very important. And let's say you have only covered parallel plate capacitors. Okay, like in the first few classes we discussed, spherical capacitors, cylindrical capacitors. Given any random shape, how do you derive the capacitance of the capacitor? Okay, how do you do for this? Again, you will do the same thing, guys. It's 1. This is 2. Right? This is 2 means this is also 2. This is 1 means this is also 1. And there is a C and there is a C. But is this in series or parallel? How do I identify that? Draw the diagram. Draw the diagram as simple. You are welcome. So generally, draw the diagram. Problems like this, draw the equivalent capacitor circuit. That's all you have to do. You will draw the diagram. This is 1 and this is 2. Okay, and again you have a 2. 2 is connected to 2. Is that what is happening? 2 is connected to 2. Okay, fine. I'm fine. Okay, I hope you understood that. 2 is connected to 2. That's why I'm drawing it like this. And next, again about 1. 1 is also connected to 1. Okay, this is 1. Okay, there is one more 1. And are they in series or parallel? Let's analyze it. Okay, let's analyze it. This is V and let's say this is of course this has to be like V and V dash has to be equal, that thing. But anyway, just for understanding, this V and V dash. Okay, between 1 and 2, if I'm going to talk about it, this is 2 and that is 1. How does this plates look? Are they in parallel or series? Should we draw the diagram again and understand it? Let's do that. Okay, I'm labeling those plates again, giving this 1 and this as 2. Maybe there it was like 2, it does not matter. So I have to find out the capacitance, effective capacitance between 1 and 2. Right? So what do you think will happen when I'm going to insert 2 plates between one plate and find out capacitor? That is one more way of thinking about it. Okay. So I have my terminal 1, I'm going to draw it this way. And there you go. This is 1 and this is 1. Right? Any issues? I don't think so, any issues. And this is some capacitance C, or the distance consecutive equal distances. Okay, that means this is 2. Right? And there you go, another 2. So this is 2, isn't it? And this is 1. So I'm going to ask you, what is the capacitance between 1 and 2? Forget this 1 and 2 and think about it. Are these capacitors in parallel or series? They are in parallel, guys. They are in parallel. If you have any doubt, you can draw it this way. I often come across a lot of confusion in these kind of problems, but all you need to do is draw them aptly, and then you'll understand whether they are in parallel or series. Again do it. If you're not just while we are starting up, you can do it multiple times, but not post them. Okay, this is 1, this is 2. Is there any difference between what we have drawn and what is given in this in this thing or in this thing? No, there is no difference. One is connected to 2, one is connected to 2, one is connected to 2, one is connected to 2. They are actually in parallel. So if they are in parallel, what is the effective capacitance? 2C. And what is the value of C? Epsilon naught A by D. But if you have noticed the question, there was a mica in between of K, dielectric constant. So it's going to be epsilon naught Ka by D. Whenever you have confusion on these kind of problems, you are going to draw the circuit diagram like this. So the answer should be B. Alright, let's move on to the next question then and understand it. So this is an easy one. This I believe most of you who have attended the class can do it. Maybe you can take a couple of minutes and have a look at it. So what is it saying? There are 3 condensers of capacitance 2 picofarads, 4 picofarads and 8 picofarads respectively, and they are connected in series and then connected in parallel. The ratio of the capacitance in series and parallel is, there was a similar JEE Mains or JEE Advanced question, I don't remember exactly. So what about in these kind of cases? First of all, go through the option of eliminating things. Series should be greater or parallel should be greater when it comes to capacitors. When it comes to capacitors, you should have the ratio on the parallel side to be greater than the series side. That means option B is already wrong. Okay. So maybe it is, we are skeptical whether it is A or D or whether it is C. Okay, so 2 similar options have been given to you, but analyze it and let me know what should be the answer. Like, let's do it in a couple of seconds. It should not take more than that, right? C series, what should be? Like 1 by C series should be 1 by C1. When it comes to capacitors, going to be the other way around of resistors. So practice as many problems on capacitors as possible before you enter resistors, or if you have already done resistors, practice as many problems on capacitors also. So it's 1 by 2 plus 1 by 4 plus 1 by 8. This is C series. Okay, I'm just writing on CS. Okay, and 8, this is 4, this is 2, and this is 1. How much is that? 7 by 8. So that your capacitance is nothing but 8 by 7. Right? And when it comes to parallel, what is your capacitance? You basically add them up. That is all you have to do. You have to basically add all of the capacitances up. C1 plus C2 plus C3. How much does that yield? I believe it yields 4. sorry, 14 picofarads, not 4, 14. Okay, C parallel. And what is the ratio of C series to C parallel? Is that what they're asking you? Okay, and that should be 8 by 7 divided by 14. Try to write things like this. I've noticed, things go here and there. So probably you had two matching options, two confusing options, and there you go. You have your answer between them only, guys. Okay, sorry, it's 7 by, I'm really very sorry, it's 4 by 49. I wrote it as 79, it should be 49, okay. And I think 7 was in my mind, so it's 4 by 49, alright. So this should have been the answer, not rest of them, quite easy. So whenever you get two matching options, you can think about it, don't guess it, guys. If you're advanced aspirant, don't guess it at all, no guessing. That's the worst blunder that you can ever do. So what about if you're given a problem like this? Why don't you do this problem? I mean, let me tell you, they're asking you what is the capacitance between X and Y. Is there anything confusing in this? Maybe the given nodes, I think so, the given nodes. But does that confuse you? What do you think should be the capacitance between X and Y? I see these kind of problems and I often think, okay, what has happened in this problem? What is the thing that we are missing while we are thinking these kind of problems? Okay, whatever the capacitance is, your battery, don't forget that you attached a battery and your battery will try to maintain that potential between X and Y. Right? Battery is going to maintain that EMF between X and Y. I often see problems like this, and students think they are in parallel. No, guys, they are not in parallel, they are in series. Right? They are in series, right? So what is the job of my battery? My battery tries to maintain the potential C by 3, 2 by C. Yes, I think so. Just a moment. 2 by C, 2 by C, 1 by C, yes. C by 3. Yes, that's correct. Yeah, you are correct. Awesome. Hi, Roshan. Pretty awesome. Vanishka, really good. Awesome. Good evening, Roshan. Good evening, Anishka. Really good. So why did I bring up this problem? You will not even get battery sometimes. They will only, map the terminal and give you the capacitor. Okay, yes, C by 3. That's correct, Dean. That's correct, yes. So what is the job? So whenever you're given, even without a battery, think about this problem as if there is a battery in between it, and the job of the battery is to maintain that potential between them. EMF between them. That is the job of battery, right? That means your capacitors are actually in series, not in parallel. It appears as if they are in parallel, but they are actually in series. C series 1 by C1 plus 1 by C2. How much is that? All of you are correct, guys. Yeah, depends on the positioning of the battery, of course. But even think about it, if I haven't given you battery and I've asked you, what is the capacitance between X and Y, it is still in series, guys. It is still in series. This is a very confusing way of asking things. Okay, this is where the mistake happens. It's just C by 2. Amazing, really good. Let's get into the next problem then. What about this problem, guys? I believe this problem should be really easy. I believe everyone will do it. Take your time. Depends on the positioning of battery, Manishka, but do remember, even if the battery is not given to you, if the battery is connected across these terminals, yes, like what you're saying, across between, like how it is given in this case, yes, that is true. Okay, if they are not connected as given in this, I mean like this, but rather like that, that is in series. Okay, depends upon the positioning of the battery, honestly. That is correct, yeah. So yeah, get started on this. This is like, a 2-second problem. I believe, good. Awesome. Yeah, that is it. So what is this, guys? So the thing is 2 and 2 in series. 1 by 2 plus 1 by 2 is equal to 1 by C. That is going to be 1 microfarad. Yes, students, that's correct. Yes, 1 microfarads. And 1 by 3, 1 by 6. Do remember this. 1 by 3, 1 by 6. If you get even such resistors in parallel, it's going to be 2. Okay, you can also work it out. 1 by 6 plus 2 by 3. That's going to be 3 by 6. That's going to be 2 microfarads. And 2 microfarads. So effective capacitance is something like this. 2 microfarads and 1 microfarad in series. Okay, in parallel, I'm sorry. So that is going to be, net is going to be 2 and 1 in parallel. That is going to be for capacitor. You're going to add them. That's going to be 3 microfarads. Sorry, 3 microfarads. Yeah, easy. All right, let's move on to the next challenge problem then. And post this, we are only going to deal with JEE advanced problem. So make sure you are able to solve this problem efficiently. We just discussed about this concept, right? We discussed about this concept, but in a very different way. Try to, so also your capacitors will be called as condensers. I hope you remember that point. Even if never told to you, and two plates have been brought together to form a condenser, they're nothing but capacitors. Okay, they'll ask you two condensers have been two plates have been brought together to form a condenser, and this condenser, how much charge it can develop given some potential across them. You should not get confused. Okay, and two parallel plate condensers of capacitance 20 microfarad and 30 microfarad are charged to the potential 30 volts and 20 volts. The likely charges are connected. Then the potential difference across the plates is what is happening in this case. Take your time, think about it. What you are trying to do over here, you are going to equate the potential on the plates. Draw the diagram. It can take a couple of minutes. Just draw the diagram and try to come up with the answer. Should we get started then? All right. So you have 20 microfarad capacitor, which is charged to 30. Which has potential difference of 30 between it, and that was before you are attaching them. Okay, this is before attaching them. Okay, not after attaching them. About this is going to be 30 microfarad and 20 volts. What you need to do, you need to connect them. If you connect them, what is that thing that is going to be equated? The potential on the plates. Let's do this. And what is the thing that is conserved? The charges. The charges are conserved and the potential will be equated. So let's do this and let's understand what is happening. So what am I saying is charge Q1 is how much? I'm not going to, I'm going to call this one as Q1 and the other one as Q2. Yes, that's correct. Amazing, Vanishka. Really active and really good. Awesome. How much is Q1? Actually, they both have the same amount of charges, if you have noticed. This is also 600 microcoulomb, and Q2 is also how much? 20 volts into 30. I'm writing it down for this one. So that is also 600 microcoulombs. Your net charge must be conserved, guys. Okay, do remember that your net charge must be conserved. So what is the total charge? And they are connected in the same polarity, that means they will be conserved. If they are connected in the opposite polarity, they are not going to be conserved. Forget it. Okay, like how we are going to see in a JEE advanced problem, or how we have seen in previous JEE Mains problem. So this is going to be 1200 microfarad. Now forget this point and let's come to this point. The potential on the plate should be equated. Okay, so I'm going to call this as Q1 dash. Earlier I was calling this as Q1. Now I'm going to call this as Q1 dash. Okay, Q1 dash by C1 is equal to Q2 dash by C2. Okay. Q proportional to C as V are equal. Yes. C Q proportional to C. Yeah, that is also correct. Yeah. And how many hours to study, Rohan? It depends. It depends. Like, it depends on what kind of materials you are referring, and depends how much time, how much energy and time you are spending on your JEE Mains and JEE Advanced. So there is also this factor that you don't want to spend a lot of time on your JEE Mains and JEE Advanced. Okay. And one more thing. So I'm going to say this as, so the potential is equated. I can say something like this. Okay. I'm going to call this as, V dash. So C1 V dash right, C1 V dash plus C2 V dash is equal to how much? 1200. Was it 1200 microcoulombs? Yes, 200 microcoulombs. And how much is V dash is what we have to find out. You don't have to do the entire thing. This is not at all required. This is just for your understanding. Okay, they will be equated. Okay, forget the Q for now. We have to actually find out the potential difference. If you have to find out the charges on the each plates, you will do this. Okay, and that is C1 plus C2 is equal to 1200. Okay, I'm not writing that microcoulombs for now. Okay, and how much is C1 plus C2? 20 plus 30. Yes, Manishka is right. She did it quite quickly because she already knew the concept. If you don't know, it's fine. This is going to be, 24. She's correct. Don't worry about it, guys. How many hours it will take? So one of the things is, so Rohan has asked how many hours it takes for, JEE to get a seat in IITs. So the thing you have to remember is your IITs are not about. So what did we do? We actually did this equal to Q total. Okay, I'll just once again complete this, and then I'll come to that point. So you're going to find out the charges on the each plates, and you're going to equate the charges and find out the potential. Okay. That's what we did. This is how much? Q1 new. Okay, dash is new. Okay, that's what we did. Nothing else. Charges should be equal when they are connected across the same kind of, polarity. If they are connected in opposite polarity, what would you do? You would still try to balance the voltage only. Okay. So one of the things is like Rohan has said how many hours it takes to get a seat in IIT. Guys, let me tell you something. Sometimes, students crack it, hi Pankaj. Sometimes students crack it even in a year. Sometimes students are not able to crack it in 2 years or 3 years, 4 years, it depends. There are a few factors that will influence your admission. One is going to be, the biggest factor is going to be that day. That day in your exam, you are well prepared, but you are not prepared for the strategy, or you are not, mentally prepared for that exam. That also messes up your exam. Next, your confidence that in the last 1 and 2 years, maybe you are preparing for 4 years. Sometimes they don't get into IITs. The reason is they become overconfident in the last year and they ignore the second year syllabus completely. Whereas if you notice, your highest weightage would be for the second year syllabus. There is no first year, second year syllabus when it comes to IIT JEE preparation. Okay, literally there is no first year, second year syllabus. But this is what happens to some of the students. Some of the students will just prepare for 6 months, 1 year, but that dedication, that students don't think about that number of hours. Number of hours at that moment does not matter, guys. I do remember the time when I used to prepare for IIT JEE. I never used to think about how many hours am I preparing for IIT JEE. That is the simplest thing you have to do. Be it any task, if you want to achieve the task, you cannot think about the number of hours and spend your time. You cannot plan. I agree, you have board syllabus, guys, but your board should be the secondary thing. You should allot the limited number of hours for your board syllabus. Rest should be your IIT JEE preparation if you really want to get into those IITs. Okay, and especially right now, you know, your syllabus is comparatively, earlier in our times it was like, if you want to get into IITs, right, all you need to do was just prepare for IIT JEE and there you go, you're done. And we don't have to prepare for, you know, JEE Mains. We just had to prepare for JEE Advanced. But right now you have a lot of syllabus, so now there is no, you know, you don't have a choice of thinking about anything else other than getting into those IITs. So you need to spend as much time as possible just understanding concepts, solving problems, and getting motivated about it. You need to be mentally prepared for it. You should start thinking in your mind that you're going to get into one of those IITs. That is very important, students. Very, 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 very important. If not, you know, even though you might prepare really well, you may not get into you know, the IIT. Okay. So yes, you need to be super focused, guys. You need to be super focused. You cannot get distracted. You cannot get at all get distracted or demotivated. So let's get into this problem. That is the key to get into, you know, into like IITs. So that being said, how do you do this problem, students? A parallel plate capacitor of capacitance C is connected to a battery and is charged to potential V. And this is the JEE Advanced problem. So think about it carefully and read the question carefully, especially if you are preparing for JEE Advanced. Read the question multiple times carefully. Okay. I didn't get your question, Pankaj. Is it enough for IIT? What is enough for IIT? I didn't get it. I didn't get it. How much? Like what you're talking about? Can you you know, be more clear about it? So yes, another capacitor of capacitance 2C and is charged to a potential difference of 2V. The charging batteries are now disconnected and the capacitors are connected in such a way the positive terminal of one is connected to the negative terminal of other. Right? Do it again. Shambhu, try to you know, do this problem again. So what positive terminal is connected to negative terminal? Yes, Vanshika, amazing, Vanshika, really amazing, really smart, awesome. Yeah, these lectures are enough for your JEE Advanced. These lectures are more than enough for your JEE Advanced. Really good. Actually, there's a shortcut to do this problem, but first of all, let's understand this problem. So what is the mistake when you are thinking the other kind of answer? You see, it's a JEE Advanced problem. Read the question carefully. Negative terminal and the positive terminal are connected. Okay, if this was negative terminal, which was, you know, the capacitor charged to, you know, V and it had a capacitance of C, then you connected it to the positive terminal of another capacitor. That is what has happened, right? I believe most of you who had, you know, made the mistake is because of this. Okay, all right. So this is all you have to do. Now you know how to work on this problem. Okay, what is the final energy of the configuration? You need to first of all find out the potential, and then you can just add the energies, or you know, this capacitors are you know, at the same potential. You can just do that. So yes, so this is what you do. First of all, until now the potentials were different. Once, okay, let's assume this was not existent. That is when this is true. This is at 2V and this is at V. Once you have connected it, they will establish same potential. Okay. Now let's understand things. Q total should be conserved, but in this case, Q total is how much? Q2 minus Q1. Right? How much is Q2? Q2, I'm going to call the capacitor with, you know, 2V and 2C as Q2. So 2C, 2V minus C and V is conserved. We did a very similar problem, didn't we? Do you remember? When they are connected with opposite terminals, what happened? We did the same thing. Okay. So how much is Q total now? 3 CV. Right? That is it. So this should be a Q total. This is why? This is because negative terminal is connected to positive terminal. Yes, Darshan. Yes, daily there will be class. Thank you, Pankaj. Thank you. And stay focused, students. Stay focused. Yeah, JEE Mains, you can attend it. I mean, you need to attend even, JEE Main. We have to even cover JEE Main syllabus, right? For your JEE advanced preparation. It does not work one way. This only happens when negative is connected to positive. Right? Else you do Q1 plus Q2. It's not Q2 minus Q1. Okay. So this is one of the things that you know. What is the other thing that you know? Other thing that you know is, these plates should establish equal potentials across them. Okay. So I'm going to call this as, Q2 dash, new one, by 2C is equal to Q1 dash by C. There is a shortcut. We'll discuss about that. Okay. And you also know QT is equal to, so this says that Q2 dash is equal to 2Q1 dash. Right. Good evening, Darshan. Good evening. Hi, Tushar. Hi. Okay. I think we are running out of pages. So the other thing we know is Q1 dash plus Q2 dash. Let's see if I have some space over here. Okay. I guess let's take up a new page then, and that should be fine. So other thing we know is Q1 dash plus Q2 dash is equal to Q total. How much was it? That was 3 CV if you remember. It can be minus 3 CV or 3 CV depending upon how you are connected it. And now what about your Q1 dash? Q1 dash is just keep it Q1 dash, and we had the other result, that is Q2 dash is equal to 2Q1 dash. Okay, that means 3Q1 dash is equal to 3 CV. Okay, so Q1 dash is CV, that is the charge stored on the capacitor of capacitance. So now what Q2 dash? Q2 dash is 2 CV, right? Now just add the charges and find the effective capacitance, and you will get the answer. That's it. Okay, because Q2 dash was nothing but 2Q1 dash, right? 2Q1 dash, Q2 dash, same potential. The potential is same. How much is the potential across them? You can do either Q square by 2C, or you can move by the other one as well, of CV square. You'll get it as 3 CV square by 2. Right? Keep it as V, and just find out the potential across them. Okay. And the other way of doing this kind of problems are, you can take up effective capacitance and also effective potential. In these cases, effective capacitance, you'll assume them to be in parallel. So parallel means 2C plus C. And how about your V? V is 2V minus V whole square. How much is that? Half 3 CV square. Sorry, this is half 3 CV square. Yes, that is one of the ways of doing it. Yes, actually it's only like what Vanshika is saying, it's only potential V across them, right? Even you can go by that method, or this is also a way. I believe Vanshika took this method of doing it. So you find out the effective capacitance, that is going to be 3C, and the potential is going to be directly, you can say it's going to be V dash. Sorry, V. So it's going to be 3 by 2 V square. And even in this case, you will get it as, the potential across them. You can find out from the charges what is the potential, it's V. Add the capacitances and do it. That was little, just to give you an idea of how to do it. Again, a JEE advanced problem. So start working on it, students, start working on it. I've come across the solutions online. There is an issue. So make sure you understand this concept. We discussed this concept during our discussion on parallel plate capacitors. We discussed distribution of charges and the energy stored across them. Now take your time, think carefully and answer it. So two identical metal plates are given positive charges Q1 and Q2. And this is irrelevant. Q1 is less than Q2. Maybe it is also relevant. But anyway, if they are now brought close to each other to form a parallel plate capacitor with capacitance C, the potential difference between them is how much? It's redistribution of charges problem, students. So think carefully and try to answer it. Put your pen on the paper. I know you don't need to do that if you have attended a lecture. If not, try to put your pen on your paper. One thing you have to do, I'll tell you one of the hints before you get started. If you have two plates like this and if you bring them together, what would happen if this is Q dash? This is going to be minus Q dash. And this is how much? This is Q minus Q dash. And this is Q plus Q dash. Okay. This this thing right? This thing though that's just like a simple concept. Try to do this, try to do this, try to do this. Alright, I'll do a thing. I'll also get started. If you don't know the concept at all, I'm just going to give you a short brief on the concept. Okay, so let's say I have a plate 1. You can actually later on go and attend the lecture and it has everything on it, but for now you can just just watch it over here. Later on go and attend the lecture. I'll anyway disclose a few small things that you need to understand over here, or a few things that you have to also remember over here. Yes, Q1 minus Q2 by 2C. Why 2C, Vanshika? How did you do it? Did you calculate the electric field? The distance is D. Okay, let's take a black color. Maybe that would be helpful. Okay, the distance is D. Okay, let's see. So standard thumb of rule is initially it was Q1 and Q2. Do remember this. You need not memorize it. Okay. So this happens, guys. Okay, you can calculate it from your redistribution of charges. Generally on this side what you would get is Q1 plus Q2 by 2. Okay, on this side as well you will get as Q1 plus Q2 by 2. Right, this happens. Okay, Q1 Q2 given to you, this will happen. You can work it out using electric field concept. You need to calculate electric field over here, and that electric field should be 0. And you need to calculate electric field over here, that electric field should be 0. And the next thing is charges over here. What do they become? Q1 minus Q1 plus Q2 by 2. That is going to be Q1 minus Q2 by 2, and over here it is Q2 minus Q1 by 2. Right? I'll just write it down again. Let's label it. That's better, I guess. So what I'm saying is just keep this as red color itself. Let's not mess it up. And let's see. What I'm saying is if this is Q1 plus Q2 by 2, this should be Q1 minus Q1 plus Q2 by 2. How much is this? Q1 minus Q2 by 2. Right? So this is about one plate. What about the other one? The other one, you know this thing. This is going to be Q1 plus Q2 by 2. And how about this side? This side, it's going to be Q2 minus of Q1 minus Q2 by 2. Charges should be conserved. There's no way for the charges to flow. So what is that going to be? Q2 minus Q1 by 2. Right? Yes, you are correct, Manchika. Yes. So what is the electric field at this point? You're basically worried about electric field. So this charge and this charge is going to nullify. Right? Think about it. This charge and this charge is going to nullify. Right? And how about this? How about this? This is going to give you some field. These both are going to give you some field. Let's do this. I think that was very small. Let's draw a large one over here. I believe this. Remember this concept, students. This is going to be always Q1 plus Q2 by 2. Okay, similarly on the other plate, outside of the other plate, it's going to be Q1 plus Q2 by 2. It comes from, good Vanshika, really good, awesome, really awesome. Okay, and this is going to be Q1 minus Q2 by 2. Stay motivated, guys. There is nothing in this concept. Okay, and how about this? This is going to be Q2 minus Q1 by 2, whereas this is always going to be Q1 plus Q2 by 2. Right? All you need to do is calculate the electric field at this point. Okay. Just a moment. I'll pick up some good color. I have to calculate some electric field at this point. This charge, let's say, is going to give an electric field of E in this direction. And what about this charge? This charge will also give an electric field E in this direction. So they don't actually produce any effect, right? They both will try to push in the opposite direction. That will be equal. And how about this? Okay, how about these two? These two will actually push it in the same direction. If Q1 is greater than Q2, let's assume there is a positive charge over here. This will and this will push in the same direction. And what is the electric field due to a plate? Sigma by 2 epsilon. If it is air, it's sigma by 2 epsilon naught. Okay, sigma is nothing but it's basically charge density, aerial charge density. You can do that later. So it's basically, in this case, if you have noticed what it is, like this is going to be Q1 minus Q2 divided by 2 into 2 epsilon naught by area. Okay, let's do that. Okay, so let's first of all write down electric field due to 1, and then what would you do? You multiply that electric field with distance. That's all. That is all you need to do, students. That is all you need to do. Okay, let's continue this. So I'm going to say electric field due to 1 is how much? Q1 minus Q2 divided by A. This is sigma by epsilon 2 epsilon naught. Yes, Vanshika, you are correct. And now what E2? E2 is nothing but, in the opposite direction, I would write it down as Q2 minus Q1 by 2. Okay. This is actually in the negative direction, if you have noticed. Yeah, you can do that by Gauss law. So what you're saying, by Gauss law, what you're going to do? Q inside by the surface. Yeah. Q inside and by C. But your Q inside is Q1 minus Q2 by 2. Yeah. That is also something that you can do. Yes, of course. Yes. Really brilliant. Awesome. So how much is E net? So but how do we get this? We actually get this from here. Okay. The equation, that the thing that you're talking about, right, Vanshika? So you get that from here only. Okay. So how much is E net? E net is nothing but I'm going to write down E net over here. I'm just subtracting them both. What would you get? So there must be by 2, sorry, by 2 and by 2. Yes, you can directly do that as well. Take one of the charges and divide it by area, by capacitance, you'll get the answer. Okay. And this 2 will add up, and I'm only going to have 1 epsilon naught. And this is electric field. And what is your potential? Your potential is nothing but into D. E into D is equal to your potential. Okay. So now if I have found out the value of E, which is nothing but Q1 minus Q2 divided by 2A epsilon naught into D, V is how much? E into D. Okay, so it's going to be Q1 minus Q2 divided by 2A epsilon naught into D. And what is the value of C? C is nothing but epsilon naught A by D. And what this should be? Q by 2C. Right? This is nothing but Q1 minus Q2 divided by 2C. Right? Which it is. That's really good. Yes. Yeah. Like what Vanshika has told that why do you need to even derive the fields? So what we did, we derived fields. So this is applicable if there aren't multiple plates. Okay. What if you have multiple plates? Then what you can do is still you can take it as multiple capacitors in series or something like that. Okay. So what she said is like you don't need to do this entire thing. Just take this inside charges, because only inside charges will create the field. So your Q is nothing but Q1 minus Q2 by 2, right? So what should be your potential difference be? Potential difference is nothing but Q by C. So your potential is basically going to be in 2 or 3 steps. It's going to be Q1 minus Q2 by 2C. Right? Yes, we are correct. It could have been done this way as well. Yeah. Hi Krishna. Hi. So that is it, guys. That is how you do it technically, and this is how you do it in a faster way. So now get started on this, Vanshika. What do you think? The answer here should be, I think this is an easy one actually. Don't get terrified. In JEE Advanced, often you will see something like this will turn up often. There will be a constant speed V with which the liquid level is decreasing. Okay, but that does not at all matter. Okay, how would you do this problem? Any guesses? See students, the thing is really simple. What is happening in this case is there is a parallel plate capacitor C with some unit area and separation D is filled between them. So unit area is told to you, so you don't have to worry about the area. So actually the distance is the thing that is going to create different the challenges in the problem. And is filled with a liquid of dielectric constant K is equal to 2. The liquid is initially filled at D by 3 and it starts emptying at a speed V. Okay, they're asking you the time constant of. So how do you calculate time constant? You need to actually first of all deduce the capacitance. Any guesses, students? How would you do this? Should we get started on this problem then? So let's do it. So what is happening over here is within this d by 3 there was some dielectric field between it, but this is reducing with time. Okay, this is reducing with time. All right. And if you find out the value of capacitance, you have found out the value of time constant. Time constant, what is time constant? Yes, C as a function of time. No, they're asking you for the time constant. Time constant is RC, right? RC, that's it. You have to multiply R into C, you'll get the time constant. Yes. It's a RC circuit. Yes. That's true. How would you do this problem? Okay, let me tell you something. If you are taking these two things, these two, different places, this d by 3 and 2d by 3, what are they in? They are in, actually it's a very simple problem, students. Okay, assume that this distance is x, not really d by 3. Okay, or y something, and this is like d minus some d minus that thing x. So what is happening over here is these two capacitors are in series. If I call this to be C1 and this to be C2, they are in series. C1 and C2 are in series, right? That means the effective net capacity, you saw the diagram. I'm just saying that this over here, it will keep changing. With time it is going to change. Some x distance is going to decrease in terms of dielectric constant, and x distance is going to increase. First of all, let's write down the value of C1. C1 initially was epsilon naught A by D. A is 1 unit area, forget A. So okay, I'm writing it down for the first time. D, what is D? In this case 2d by 3. Okay, this is just initially. Okay, let's think about what is happening after some time. Do remember C1 and C2 are in series. Okay, and what about C2? C2 is epsilon naught into k, right? Or k into epsilon naught. How much is k? 2 into 1 divided by d by 3. How much is C2? C2 is something like that. This is initially. Okay, I'm just erasing this and writing that k over there itself. Okay, so this should be 2 and this should be just epsilon naught 2d by 3. Don't get confused once you see these kind of problems. There is nothing, guys. Okay, so let me tell you something amazing that is going to happen now. Now after some time, hi Jashwant, hi. What is happening after some time? After some time, some x level is being emptied. Let's assume x, x amount of dielectric has drained, or x amount of whatever, like dielectric has reduced, whatever, you can write it down. X, y, anything. X amount of dielectric drained. Okay, drained or reduced. In this case they are just saying it is flowing out, so I'm writing it down as drained. That means this distance now, I'm going to label this one as C1 dash. C1 dash has become epsilon naught 2d by 3 plus x. And how about C2 dash? C2 dash has become 2 epsilon naught d by 3 minus x. Now you know what to do. What is the value of x, guys? Velocity into time. That's it, right? Isn't that x? What is the value of x? X is nothing but just velocity into time. Just write down the equation and substitute x. Right? You can do that. So what is C effective or C net? Okay, let's take some space. I don't think this much space. It's little mathematical. Okay, don't worry about it. C net is equal to C1 dash C2 dash divided by C1 dash plus C2 dash, because they are in series, right? So what is your C1 dash? It's epsilon naught 2d by 3 plus x. Epsilon naught by 2d by 3 plus x, and this is going to be epsilon naught d minus 3 minus x, and you would have a 2 due to the dielectric constant. Okay, you are going to add them on the denominator. That is going to be super easy, don't worry about it. So you'll have epsilon naught. It's little calculation intensive actually. 2d by 3 plus x plus of d by 3. Good, amazing. That's it. That is all you need to do. Okay, even if you haven't known the concept yet, try to just solve the problem. Okay, as soon as you came to know the concept, that will improve your numerical ability, guys. Okay, this is just going to be d, right? D minus 3, d plus 3. This is just going to be d. Sorry. I think one mistake happened over here. What was that mistake? Mistake was this. This is epsilon naught 1 by 2d by 3 plus x, and this is going to be plus of 1 by d by 3 minus x. Okay, you don't have to think much, just yes, yeah, it's x is equal to vt. Yeah. X is equal to Vt, and you substitute that, you will get your answer. Okay, so because it is reducing by x with some time, this is at some time t, understand that. Okay, at some time t. Okay, initially the answer would have been very easy. Okay, and in these kind of problems, right, you would get common denominator, they would get cancelled out. Okay, you can just add them, and you will notice something like this. Epsilon naught would cancel out, and this is going to be d by 3 minus x plus of 2d by 3, and that is going to be epsilon naught. So unit area 2 epsilon naught d by 3 minus x d by 3 plus x, and that should be So there is a catch in this. No, yes, there is a catch in this. The issue is we missed this 2. So don't miss out this 2. I think I miswrote it. I missed out this 2. Don't do this mistake. Okay, there should have been a 2 over here. So you will get it. Okay, the 2 would come due to the dielectric constant. We wrote a 2 over here. We missed out that 2. Okay, that 2 should be there. Don't miss it out. Okay, just in in the urgency I missed it out. So it's going to be d minus 3 plus of just these things are going to get cancelled. I'm going to directly write it down as this divided by 2d by that has become sorry guys, sorry. So this is going to be d by 3 minus x plus of 4d by 3 minus 2x, right? That is what it is. Yes, that is what it is. So you would get it as something like 6 epsilon naught. You can solve this. I don't think we have further space, so you can solve this, and this would be like minus x, and this would be like plus x, I guess. This will be plus x. So, and this would be minus x. So this would be like just 1x, and you would get it as 5d by 3. 3 goes on the top, that is going to become 6 epsilon naught, and this is 5d, right? 5d, right? 3 and 3 common, 5d, and that is going to be plus x. And what is the value of your x? Like what Vanshika said, it is nothing but Vt. Work it out, work it out, work it out. We just did it, right? We wrote down the value of C dash, we wrote down the value of C2. You can work it out. Okay. Going to be 5d plus 3Vt actually, okay? There should be 3Vt. 3x, you get a 3 over here, right? Once that is going to carry out. Okay. It's really simple. 1c by 2, yeah, that is true. Really interesting, huh? Yeah, that is true. You could have done also, 1 by c dash plus 1 by c2 dash. Really quick. Amazing, Vanshika. Really good, really good. So, how about this problem, students? Really good, really insightful, yeah? Really smart. A uniformly charged thin spherical shell of radius r carries uniform surface charge density of epsilon per unit area. It is made into 2 spherical shells and they are held together. That means there should be a repulsion force, and you are basically trying to keep them attached by using F and F. They are just asking you what it is proportional to. Yeah, you could have actually, this is also a very interesting way of doing it. You need not have done this entire calculation. I'm just erasing it for a moment, guys. So one of the students have come up with very easy way of doing it. Okay. So what you can like after this lecture you can rewind it back. So 1 by c net, this could have been easier. 1 by c1 dash plus 1 by c2 dash. How much is that? That could have been like even far more faster and efficient. Sorry. So this is nothing but 2 epsilon naught d by 3 minus x, and this would be 2 into, yeah, we need not have complicated things. Really brilliant. Okay, so you basically take epsilon naught, 2 epsilon naught as common, and you multiply this again with 2. Just a moment. How did we get 2? There is no 2 over here. Okay. There should be 2 over, there should not be 2 over here. This could have been rather very faster, right? Rather than going through the entire hassle, you could have just added them both. This way. Just make a common denominator 1 by 2 epsilon naught. This is nothing but d by 3 minus x plus of 4d by 3 plus 2x. It's simple to calculate. I mean, maybe for some of you it takes same amount of time, but that's really brilliant. Okay, so this is going to be how much? X 3x 5d plus 3x into 6 epsilon. Same thing you are going to get. C net is equal to 6 epsilon naught divided by, really good, plus 3x. How much is x? X is nothing but, just substitute x is equal to Vt. Really good. So yes, about this problem, you have 2 MSPs and you want to keep them attached to each other. So how would you do this kind of problems? Okay, so they notice the problem. Generally in JEE Advanced there would be a trick. They're only asking you what it is proportional to. This is surface charge density, not the charge itself. And the options are given as 1 by epsilon naught epsilon square, 1 by epsilon naught sigma square r square, 1 by epsilon naught sigma square r, and 1 by epsilon naught sigma square r. That is sigma into r, and this is sigma square by r, and this is sigma square by r square. How do you hold them together? What is that repulsion force? Is there some Coulomb force between them? This is not exactly a capacitor kind of problem, but if you remember, we did a problem where we had two plates and there was some force of attraction, force of repulsion between the capacitor plates, and you had to do some work to move them together. Now you're trying to hold those both spheres together. How would you do that? Any guesses? See, one of the things is you can directly notice a few things. One is your Coulomb, you can go by Coulomb's law. That could be simple. F is equal to Q1 into Q2. I mean proportional to Q1 and Q2. Just a very 2-second method of doing this kind of problem. Okay. So that being said, your force is proportional to Q1 product of the charges, which is nothing but sigma square, and your sigma square by sigma square into 4 pi r whole square. Okay, something like r square would be there, and your force is also proportional to, so that r to the power 4, sorry, r to the power 4, and your force is also proportional to 1 by r square. So what should be a force be? Actually, it's a capacitor plate problem. It should not be done this way, logically speaking. So this should be like like F is proportional to sigma square r square, something like this you should get. There should be some constant. Probably the answer is just A. Okay. How do we do this? See, this is the way to go about it, students. So this is the simplest way to solve the problem. Don't spend a lot of time thinking about these kind of problems when you get them. The other way to go about it is, you would say on the plate 1 due to the plate 2, the charge is going to be sigma by there's going to be sigma by 2 epsilon naught, sigma square by 2 sigma by 2 epsilon. You are going to calculate the electric field E1. Okay, that is going to be sigma square by 2 epsilon naught. Believe sigma by 2 epsilon naught, in this case kq by epsilon naught, sigma into a by 2 epsilon naught. Okay, sigma sorry, I'm really sorry guys. Okay, sigma divided by 2 epsilon naught into area 2 pi r square, sorry. Okay, 2 pi r square. I'm really sorry guys. Okay, this I've confused you. So it is k cube by epsilon naught, right? K cube by r square, where k is 1 by 4 pi epsilon naught. Okay, so 1 by 4 pi would be also be there. 1 by 4 pi epsilon naught r square into area, that's going to be 2 pi r square, because they are the hemisphere. And what is the force on the charge due to one charge and another charge? That is basically nothing but Q into E. In this case, Q into E1. One of the forces is what we are assessing. Both the forces are equal. Yeah, assuming they have equal charges on them. How much is that? 2 pi r square. This should be 2 pi r square. Hi Lovish, hi. So that could have been the shortest way of doing it. Yes, you can do it even this way, and that is going to take a lot of time, I believe. And this should be like sigma into 2 pi r square, and you come to know that your this thing is proportional to this 4 pi gets 4 pi 2 pi and another 2 gets cancelled. So, and you'll also have 1 r square cancelled out, and your force is proportional to sigma square by sigma square into r square by 2 epsilon naught. Okay, sigma square r square by 2 epsilon naught. Right, this is another way of doing it. And also do remember, when we are talking about capacitance plate, we wrote that it's directly sigma by epsilon naught. Also go by that way, and in that case what it would be, and this should be sigma by also 2 epsilon naught. This can be done another way as well. Okay, there are multiple ways of doing it, but that could have been the easiest way. So this way also you can tell it is proportional to sigma square r square by epsilon naught. Okay, go by Coulomb's law, that's the easiest one. So let's move on to the next problem then, and let's get started on this. A 2 microfarad capacitor is charged. So this is a very interesting problem, students. Okay, really interesting problem. Think about it and try to answer the question. Okay, and there is a 2 microfarad capacitor. I believe lost my okay, and it is charged as shown. A 2 microfarad capacitor is charged as shown with some V potential. And this is the 2 microfarad capacitor, and the switch is turned to the position 2. Okay, that is with 8 microfarad capacitor. Now what would happen? What will happen, guys? How do you do this problem? Do you remember you have to equate the potential? A square, I didn't get it. I didn't get A square. What do you mean by A square? It is not A square, guys. Okay, it is sigma. Okay, I guess one of the students have doubt in this. This is sigma, this is not charge. This is charge density. Charge density per unit area. Okay, what is charge density per unit area? Q1 by A. And what is your Q2? Like sigma is also Q2 by A. Hence you have that A square, R to the power 4. Okay, let's move on then. Let's get started on this question. So as usual, they are saying after a long time, generally questions like this after a long time. And how do you do this question? It's really simple, guys. It's really simple. You need to first of all understand that your charges are going to be conserved and the potential has to be equated. Okay, same kind of. You didn't understand this problem? Maybe you can do it at the end, or maybe in the special class. So this is Coulomb's law, right? Force is proportional to Q1 and Q2. What is Q1? Sigma into A. What is Q2? Sigma into A. You can notice these two things over here. Sigma is what? Q1 into A, and sigma, like Q2 is what? Sigma into A. So they are going to be proportional to sigma into R to the power 4. And as per your Coulomb's law, there is also inverse square relation between the distance. Hence, from these two equations, you get it as it's proportional to sigma square r square divided by epsilon. Good, really good. Amazing, Manishka. I hope you will definitely get into one of the IITs. I believe so. These are like advanced problems, and you are able to solve it within the given time frame. Yeah, that is really amazing. Okay, so what is the total charge? 2V initially, because this was charged to V, so this initially add like a potential of V initially. Yeah, she's super fast. That's amazing. Also you are getting all those, that's brilliant. Okay, and Q1 Q2 initial, I'm talking about initial condition. Initially Q1 was 2 microfarad into V. Okay, I'm not writing down the 2 microfarad because everything is in microfarad. Okay, and Q2 is 0. Later on, what happens is Q1 by C1, once the switch is closed, just a moment, let me write this down properly. Okay, that is pretty fast. Okay, and this is Q1 is equal to 2 volts, 2 CV actually. Okay, this 2 came from this 2, it's not 2 V. V is how much discharged. Okay, initially this is the case. Once switch is closed, so how much is Q total? It is Q1 plus Q2, which is only 2V. And once the switch is closed, what is happening? These two potentials will equate. Q1 dash is the, let's assume Q1 dash is the new charge, by C1 is equal to Q2 dash by C2. I hope everyone is understanding this concept. Okay, Q1 dash is equal to 2 by Q2 dash by 4 by 8, sorry. Yeah, that is, you need not thank me actually, that is pretty fast. Okay, so you could have done it the other way as well, but don't do the mistake of half of C1 plus C2 by V square. That would go wrong. Okay, in many of the solutions it is given as half C1 plus C2 whole square. I don't understand the logic behind it. Okay, and this thing, so this is after switch close. That's what we are analyzing now. That is what we need to analyze. After S is closed, this is what is equal to, so Q2 dash is equal to 4 Q1 dash. I think C1 plus C2 whole square, what would you get? Whatever, I don't know. Maybe that way also it can be done. There is a shortcut for this. Yeah, there is a shortcut for this, guys. I'll discuss about it. Okay. Okay, and how much is this? This is going to be Q2 dash, and this is Q1 dash, and Q1 dash plus Q2 dash is equal to Q total, and that was 2V. So how much is Q1 dash? Q1 dash, you substitute it over here. This is going to be 2 by 5. There would be a V. V is actually not relevant. You know that this V is coming because this is capacitance. Okay, and how about Q2 dash? Q2 dash is going to be 4 times of this. Hold on. Let's do a thing. Let's not spend a lot of time over here. Let's just find out the potential and move on. Yes, that is also other way of doing it. And this, how much is the potential now? Q1 dash by C1 dash. C1, okay, there's no C1 dash. So this was for Q1 dash was for 2, so that is going to be 1 by 5 volts. 1 by 5. Okay, 1 by 5 V, not volts. Okay, in this case it's 1 by 5 V. V by 5. Okay, whatever it is, V by 5. And the potential is going to be equal. So what is the energy due to 1? E1 is equal to half C V dash, okay, I'm calling this V dash, V dash square plus of half C2 V dash square. Okay, let's see how much we get. Yes, 80%, that's correct. That's amazing, guys. Yeah, yeah. That is also a way of doing it. So you said Q total divided by C1 plus C2. Okay. So I'll come to that point as well, because if you remember during the discussion we said that this is going to be actually in series. I'll come to that point. Maybe everyone is not yet accustomed with that thing yet. So how much is this? V square by 25. V dash is V by 5. From here I'm just directly, from these two equations I'm directly writing it down, and this is E total half C1 V dash square plus half C2 V dash square, and this is going to give me 1 by 2, and this is going to be 10, and so in 2 by 5, I guess. Okay, so I'm just writing down V square by 2 for a reason. This is something like 2 by 5. This is E total, and what was your E initial? E initial was nothing but half CV square, half V square into C, same thing. What is this? Just subtract this to find out the energy loss. E total minus E initial divided by E initial. Okay, they have asked you loss, right, or the change. Okay, loss. Okay, how much is that? Just take out V square by 2 as common. They will get cancelled out. That is going to be 2 minus 2 by 5. So you have to do percentage if you get 0.8 or something like that, and this is going to be 2. Okay, how much is that? 10, 8 by 10. Is that what it is? Yes, that is what it is. That is 0.8, 80%. This is nothing but 80%. So I'll come to that, this thing. Yeah, 80%. That's amazing, Madhusu. Yeah, Madhusu. That's amazing. So the other way of thinking about it is, okay, this is how you go typically. This is how you are supposed to solve it. But now, I'm going to erase this, guys. You can note it down. Take down the notes. To get into the habit of taking down notes in my class, because I tell you multiple ways to do this. Charge is going to be conserved. What is total charge? 2 microfarads into V. Do you remember I told you something? Once the switch is closed, they are not in parallel, they are in series. Okay. So if I told you, so what did you say? 2 by half CV square. Hold on. So you can go by Q square by 2C, but they're not really in parallel though. Okay, sorry, they are in parallel. I'm really sorry, guys. They are in parallel, right? I'm really sorry. They are in parallel. I'm sorry. That's my mistake. Sorry, I'm extremely sorry. So they are in parallel, if you notice it. So once you connect this potential has to be equated, V dash and V dash. That means they are in parallel. And here also the potential will be equated. V dash and V dash. Okay, negative V dash and negative V dash, whatever it is, okay. So that means they are in parallel. You can directly write it down as 2 into V whole square divided by 2 into C1 plus C2. How much is that? 4V square by 2 into 10. Is that what it is? Just a moment. So this is not giving us any 2V square by 10. That's 1 by 5V square. Okay. So your new energy, this is E new. How much is E new coming out in this case? E new is coming out as V square by 5, isn't it? V square by 5. E square by 5. Okay, and what about your E old? That was just half CV square. This way we are not getting the answer, right? Just a moment. So we should be getting 2 minus 2 by 5. We are not getting 2 by 5. We are just getting only 1 by 5. Half CV square. How much is this? CV square Q square by 2C. Does not matter if I take half CV square or okay. This is old calculation, right? That's correct. This is E old, and the loss is equal to E old minus E new. Yes. Okay, there we just kept the half just like that. And now let's do a thing. I guess stop subtitles and E old. Yes. They are actually in parallel, right? They are not connected across the battery. I'm really very sorry, guys. So E new divided by E old. How much is that? So just forget the V square. Okay, that is basically 1 minus 1 by 5 divided by 1. Okay, so it's basically 4 by 5 into 100. That is going to give you 80%. Yeah, true. That's my mistake. Okay, potentials are equated, so they are in parallel. Really my mistake. Okay. So let's move on to the next question, and now you have different capacitor combination. There are 7 capacitors, each of capacitance 2 microfarad, and they are connected in a configuration to obtain an effective capacitance of 10 by 11 microfarads. And which of the following combinations shown in the figure will achieve the desired result? Yeah, that was an easy one. And how about this? So one of the things you can do over here is, I'll tell you a small trick to solve this kind of problems. When given multiple options, they are asking you whether they are in series or parallel. Okay. Do remember, this is capacitor question, right? They each have some capacitance, forget it, okay? And now if you notice this value carefully, 10 by 11, how much is this? This is less than 1. Yes, Mahir, that's brilliant. Yes, that's true. Yes. That's A. Okay. So 10 by 11 is less than 1. Okay. So in these kind of problems, you can understand that most of your capacitors, they are 2 microfarads. If more than let's say less than 10, but little near about 1. Okay, this is not less than 1. This is near about 1. This is near about 1. That means many capacitors cannot be in series combination. If it was resistors, you would apply the different technique that we discussed earlier. So that means D and this cannot be the answer. Okay, D has how many capacitors in parallel? I'll show you a bigger diagram. Okay, so I think it's the same kind. So in C, how many capacitors are in series? Just a fast way of doing it. How many capacitors are in series? 4 capacitors are in series. How much should this 4 capacitors yield? 2 by 4. So your final answer should be less than 0.5 C or 2 by 4, 0.5 0.5 microfarads, or what is given to you? Microfarads. Okay, 0.5 microfarads, which is not true. Your answer is going to be, just try to understand this point. I'm just going to write down this as A from now. It's going to be less than 0.5 microfarads. Just a fast way of doing it. And how about this? Even this is not possible. Actually, there should have been one more capacitor. Okay, even this is not possible. Okay, 5 capacitors are in series, it should be less than 2 by 5. Okay, and if you notice this and this, there might be a speculation. So you literally only need to work A and B. Okay, that is fast, Mahir. Okay, I hope you are understanding this point. So what I'm trying to state over here is, notice the value. The value is near about 1. Okay, near about 1 means it's literally not more than 1, it's literally not less than 1. The C net is equal to, it's less than 1, but it is near about 1. This C would not yield that answer, because your final answer has to be less than 0.5 microfarads, 2 divided by 4, and in this case it is 2 divided by 5, which means it has to be less than 0.4 microfarads, but you know your answer is somewhere near 0.9 etc. Okay, now between these two you need to make the decision. This is without getting into the entire calculation. You're calculating A, B, C, D. If it's a multiple correct answer or something like that, you don't need to do this. Okay, you can simply try to answer from here. And now what about this? Now in these both you need to make a decision. Okay, here 5 are in parallel and there is 2 in series. How much is this 2 in series? That is going to give you 1. So this is also less than 1. The answer is less than 1 in this case. And how about this? In this case, find it out. C plus C plus C. Sorry, C by 3. How much is that? 0.66. Is that what it is? That means B is also not the answer. You could have directly stated that A is the answer, just like how we did in a resistor combination, right? This is a way of guessing things without even doing the math. You can do the math. I'll show you the math. Okay, first of all, I hope everyone understood what I discussed over here. Okay, let me reiterate it if you didn't understand this point, how to simply solve it. Here 4 capacitors are in series. Okay, I'm writing down answer as A for each one of them, just like this. That means if these 4 capacitors are in series, again in series with these 3 capacitors in parallel combination, your answer should be less than 4 by 5. Sorry, 2 by 4, which is nothing but 0.5 microfarads. How about in this case? In this case, your answer should be less than 2 by 5. Okay, since there are 5 capacitors in series, observe this point. Okay, how about this? Here you have 3 capacitors in series. How much does that give you? I hope you are understanding this point. Okay, your 4 capacitors are in series. Yeah, elimination will save time. Actually, to explain you, it's taking time, but think about it, you solving it. Your answer should be less than C by 3. Because again, this C by 3 is in series, it's some large C, but your ultimate answer is going to be less than C by 3. You can calculate it and verify it. Something less than 0.6 microfarads. I think this one I'm not able to write down clearly over here. Let me take it on the top. Okay, I hope you're getting this point. Your C net in this case should be less than C by 3, which is nothing but which is equal to 2 by 3. How much is that? It's less than 0.66 microfarad. Nothing can be the answer other than A, guys. You can calculate it. 5 capacitors in parallel. How much does that give you? 10 microfarads. And how much is this? This is 2 capacitors in parallel. That is going to be 1 microfarad. 1 microfarad and 10 microfarad in parallel. What should be your C net? C net should be 10 into 1 divided by 10 plus 1. That is going to be 10 by 11. But what I told you was, if even very, very big values were there, you can still do it. Got it? That is it. That is it, students. You don't have to work very hard around this. So let's get into the next problem then, and let's understand how to do this problem. So given to you a parallel plate capacitor of plate area A and separation D, and what is happening is it is charged to a potential difference V and the battery is disconnected. Okay, a slab of dielectric constant K is inserted. If Q, E and W denote respectively the magnitude of charge on each plate, the electric field between the plates and the work done on the system in this question, in this process of inserting slab, then which of the following are true? How do you do this question? It's a very simple question, okay? It's a multiple correct answer, guys. You are on JEE advanced problem. It's a multiple correct option question, so carefully. Do this thing very, 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 very carefully. Okay. First of all, let me tell you something. What happened? There was, there was a parallel plate capacitor and it is charged and it is disconnected from the battery. We did a lot of model problems around this. That means it is an isolation. Charges remain conserved. Charges do not change. So initially, if you have charged it with with potential V and air between them, the charge is going to remain epsilon naught A V by D. This is not going to change. C into E. After you have disconnected it, you inserted a dielectric slab of dielectric constant K. Okay, so that is going to impact few things. What is that going to impact? First of all, electric field. I didn't get it. What is H? Hi. So get started on this, students. How do you do this? Now if you insert, what is going to change? Of course, your electric field is going to change. Your electric field is going to reduce. It's going to be V divided by K by D. E initially was, okay, I'll come to this point. So let's say Tata G, hi Tata G. So that is like, you inserted a dielectric slab. Q will remain constant. Initially you used, potential V and, potential V and the dielectric constant was 1. Your Q initial is equal to Q final, which is equal to epsilon naught A by D into V. This does not change. Q is equal to CV. Okay, but once you inserted the dielectric slab, if you remember, there will be a polarization and the field will decrease. So what will be the field, new field be now? It's basically E old. Okay, electric field, right? I'll write it down with the E capital E, not like the EMF E. E old divided by K is equal to your E new. Okay, then what is your E new? Just think in terms of potential. If initially you had a potential of V between them, and if you add distance D between this, there is a distance D between these plates, and divided by K. Okay, because E volt was how much? E volt into D was V. Yes, ACD. That's correct. Brilliant. So yes, Vanishka, keep practicing. That is the key to get into your IITs. Okay. And what is this half CV square? Is that what it is? And why do we have 1 by K over here? Can someone tell me why 1 by K? Why did the energy reduce? Since the charge is constant, what you have done over here is you need to do some work, positive work, to insert this dielectric slab. Negative work to insert this dielectric slab, actually, sorry. Right? Yeah, E volt minus E new. Yeah, negative work to insert this dielectric slab. So if you observe this point, Q is constant. It's always going to be Q. Q cannot change. Q is constant. We discussed this concept, right? Q is constant. What is your now the new energy? New energy is nothing but Q square by 2C. You're not going to use half CV square. Potential can change. Potential between the plates can change and will change. It will become B by K. Okay, since there will be charge polarization, depending upon what kind of like plate it is, there will be a charge polarization, and your potential will decrease, your electric field will decrease, your charge will remain constant when it is disconnected from the battery. Do remember it. Isolated place, disconnected from the battery, it is going to remain same. Charge is going to remain same. Q square by 2C. And your Q, your Q square, just keep Q square as Q square. And I'm going to say this is, K into C volt. Okay. C volt, what is C volt? C volt was nothing but epsilon naught A by D. So that does not matter. So your work done. How much? Actually, it should be E nu minus E volt anyway. So it's a negative work done, right? Because the energy has reduced. That means so Q square by 2C is equal and this is going to be 1 minus 1 by K. And this C volt, okay? This is not C, this is going to be C volt. Your capacitance has changed. Actually, logically speaking, the charge hasn't increased, but your capacitance has changed. Your capacitance has increased. If you again connect it to battery, right, you'll understand that the capacitance has increased. The ability of the capacitor to hold more charges has increased. But if in isolation, if you connect it like this, you would get a negative work done, or you would, in fact, lose some energy due to the charge polarization. Yes, the field would decrease, everything would decrease except for the charge. So from here, the C volt, you can substitute it and you can get the value. So your work done, W is going to be, Q square by 2C, and your Q, we have the value of Q. Yeah, you can substitute all of those and get the answer, okay? That was epsilon naught, A, I think A by D whole square divided by into something like V square divided by epsilon naught divided by 2 epsilon naught A by D. You can cancel out this and this, and this is, so we discussed this concept in depth with some amazing simulation students. You can later on check it out. And this is going to be epsilon naught A by D by 2D V square into 1 minus 1 by K. Well, you understood it there itself, but you should not do the entire thing in your exam. Once you understood it, it is fine. This is just for you. Okay. All right. It should be A, C, and D. Amazing, 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 Manishka. Really good. Alright students, keep sharing this video, keep sharing this channel, talk about it with your friends, share on all the possible social media, and students who are cracking the problems, be regular to the class. You come up with amazing methods to do it, especially Vanishka. It was amazing, really, really good to have you on the lecture. Do attend all the lecture series. I come every day at 7:30. Do join our Telegram channel and keep sharing it, guys, because sharing is very important. It's a free of cost initiative. You must share it online on the all possible social medias, on every social media platform that you have, be it your WhatsApp, your Facebook, your Twitter, or your Telegram channel. Do share it with your friends on your groups, and because sharing knowledge helps grow your knowledge, you can brainstorm with your friends and understand more and more. And students, keep smiling, never stop smiling. It's important that you always keep smiling. And guys, yeah, keep smiling, and kill your ego. Your ego is not very important. If you're not able to solve it, work hard, understand the concept, ignore gossips, and kill your ego, guys. That's very important. Your ego is not at all important. And value love, keep smiling, and work hard to achieve your success, but also work smart and acquire knowledge and share it, guys. And students, if you haven't yet got onto our Telegram channel, do check out our Telegram channel. First of all, you need to download the Telegram app, and then what you'll do is you'll just click on to this link available in the description box below, or you can just type in JEE_English to connect with us on Telegram. And guys, you'll get all the live updates on every classes that are happening every day, and we are conducting classes from the basics until your JEE advanced level. So make sure you attend every class, be it on your YouTube channel or on Unacademy app. We keep conducting many classes on your Unacademy app. So this is a special class that is going to happen on this coming Sunday from 11 a.m. to 2 p.m. where we are going to cover the projectile motion concept until your advanced level. Everything that you need, every single concept around projectile motion will be covered in this class. So make sure you attend it, and you don't have to don't forget to attend this class. It's going to be an awesome class with all the awesome concepts that will be covered in a single class. Okay, it's a one-shot lecture. And students, we have already covered color coding of resistors and also electrical instrumentation in one shot. So do attend the electrical instrumentation one shot, especially JEE advanced aspirants. This is important, but maybe not the most important thing for JEE advanced. For your JEE mains, of course, it's very important. If you're 2021 or 2022 aspirant, do attend this class. But if you are a JEE advanced aspirant, go and attend the electrical instrumentation class that was conducted on 1st of September. Everything we covered in one shot, and you in fact have all the concepts from potentiometers, meter bridge, like voltmeter, ammeter, shunt resistance, etc. in single class. So do check it out on Unacademy learning app, guys. And how to attend many such special classes free of cost. Special classes, all you need to do is download Unacademy learning app. You need to type in Unacademy on your Google Play Store and App Store, and the first search result will be your Unacademy learning app. And then you'll click on the install button, and there you go, guys. You'll have this amazing app. And especially if you're a plus student, you want to have the app to get timely updates. And by downloading the Unacademy learning app, you'll get all the live updates in time on your mobile phone itself, and you can attend classes from anywhere. And that being said, students, if you're looking for an awesome special package for your JEE preparation with all the kind of technology that you need, we provide that. It comes with live quizzes, live test series. Not only that, you get to learn from your favorite teacher, and moreover, guys, it's a very structured program. You get to attend all the twice in a week quizzes, and also many more things like your test series, your competitive test series with all the like the aspirants, so that you come to know about your standings and you will improve on it. Not to say we have the best educators across the nation on this platform. So do check out this platform, and all you need to do is choose the plus and then choose IIT JEE as your goal, and then you will get the subscription. And that being said, guys, the price is pretty economical. We have anywhere around 6,000 to 7,000 plus course materials just for your JEE preparation, be it your JEE mains or JEE advanced, and moreover, 1,500 active courses running on Unacademy learning platform. And guys, the 24-month subscription, if you go for a 24-month subscription, it's only going to cost you 2,100 per month, which is quite economical. All you need to do is apply Murli Live coupon before purchasing it. Do not forget to apply Murli Live coupon. If you forget that you're not going to get this price, this is the best price. Do understand it's a value platform that gives you everything that you need for your JEE preparation. So don't hesitate to get this subscription. We also have popular authors like DC Pandey sir on this platform. And see you in the next class. Take care, stay safe, bye-bye, be regular to the lectures. Don't stop solving the problem. Just keep solving it, keep learning. See you in the next class, students. Take care, stay safe, bye-bye.